Hi, everybody. Welcome back to Chem 140. Today, we are going to name all the things. Everything. We're going to name all the different types of compounds we've encountered, and even some that we have not. Those are acids. We'll talk about that later. What do we have on the agenda as far as Administrivia? It looks like lab worksheet number 3 is due tonight. That is Thursday, the 18th. Get that in by midnight if you can. That is a soft deadline. The closing time for that will be tomorrow, but nobody wants to work on Friday, right? So might as well get it done tonight, yeah. A quiz was posted last night around 2 a.m. when I remembered, because that's how I do things, I guess. That quiz is for Units 9 and 10, and that will be due next week. I believe the deadline was Wednesday that I set. Soft deadline, so the close date on that would be Thursday. There's also going to be a quiz for Unit 11, and you're going to notice that as we get towards the end of the quarter, these quizzes kind of stack up on top of each other, because we still have like 4 more quizzes, and there's only 3 more weeks, right? So don't let the quizzes pile up on you like Tetris pieces, because they will. And then when everything is due at the end, and you're like, oh crap, I have to turn in like 5 things. Like across different classes, of course. I mean, it's just 2 of them might be chemistry. Like, then that's the time to panic, and you don't want to end up in that situation. So, pardon me for a second. Something just got in my eye. It was not a cat. Oh, Maya wants to say hi anyway. Let me rub my eyes real quick. Come here. Come here. Say hi. Say hi. Hi. Yeah, nobody's in the chat, so they can't say hi to you back. Maya doesn't understand how this works. She just thinks, oh, Wes is in the chair. It's time to bug him. All right, so the first section we're going to go into is just which of these 3 types of molecules do you have? And you can see the 3 types of molecules right here. So a molecule is either going to be ionic, molecular, or acid. We're going to devise a naming scheme for each of these categories of molecules. And so the first section is just, can you sort them? Presumably you can. It's not difficult to do. And then, once you have sorted them, can you apply the correct rules? That's much harder, because a lot of these rules are very similar, and so we're going to have to be very careful to keep them distinguished from one another so that we don't accidentally conflate them. All right. What is this scheme called to a chemist from, I don't know, from Fancy Pants Town? It's called nomenclature. The nomenclature is the set of rules that we use to define the proper way to describe a compound. And so nomenclature is very, very systematic. You follow the rules and you follow them this way every time. And that way you'll get the same result every time, no matter what the compound is. That's important because if you're trying to communicate a chemical to another person and that person doesn't necessarily understand your language, they can at least follow nomenclature, because the rules are the rules no matter what language you speak. And so the result that you get should be universal. Now, there might be some translation issues, such as, like, I don't know, some chemicals are pronounced differently in other languages or whatever, but the gist is the same. And so, like, this is a good starting point for that. Now, the treacherous part of this is that because all the rules are very similar, yet are still unique, so the rules are unique, but you can get slightly wrong answers if you apply the wrong rule set. You have to do this correctly. If you put a letter in the wrong spot, wrong. If you put a space in the wrong spot, wrong. If you capitalize something incorrectly, wrong. Be meticulous with the rules. And I'm even going to highlight that in a different color here. On your quiz, you are going to be entering names of compounds by spelling them. If you make a typo, wrong. Canvas will just mark it wrong and I will not correct you. You will not get partial credit. Be careful about the rules, because it's really easy to accidentally throw in a prefix or put in a Roman numeral where there shouldn't be one. Wrong. Okay? I'm going to teach you the right ways to do this, but you have to practice this, okay? Don't just look at the rules and go, oh, that's easy, and then I'll follow them on the quiz, because you will get them all wrong. And that's no good. Now, the first step to categorizing anything and then applying a rule to it is first figuring out what category you're sticking it in. And there are 3 categories that we're going to cover in this class, although one of them is a little bit broad and has 2 things in it. So here's that first one. So anything ionic follows the same rules. We're separating out polyatomic just because polyatomic ions come from that list that I made you reference in unit, I want to say it's 5 or 6. So those are going to follow one set of rules. Then we got binary molecular compounds, or covalent compounds, which we looked at in the previous unit. Those are going to follow their own set of rules. Then we have acids here. And acids follow their own rules too. Now, how do you differentiate between these? Well, we're going to use the ionic and covalent rules that we discussed last chapter. Something is ionic if it has a metal in it and a nonmetal, or if it has ammonium in it. Something is covalent if it contains only nonmetals. That's nothing new. But what about acids? What are acids? Acids could be ionic or covalent looking, but they have a key giveaway. And that key giveaway is that the formula starts with H. And this is very nearly universally true. And I have written down there some exceptions exist, such as H2O. Technically, H2O isn't an exception, but H2O is the limit of what we define as an acid. Like, if you are a weaker acid than water, you're a base. Because water is neutral, but it still does behave as an acid, believe it or not. We'll talk about that in 163. But we're not going to name water using the acid rules. We'll just name it dihydrogen monoxide. All right, so be on the lookout for, is the first element listed H? If it is, that's an acid, and you need to use the acid rules. All right, so let's categorize these compounds into the appropriate category. So I'm going to just go looking for, I need a darker color because I can't see it on this monitor. Yeah, that's better. Okay. I'm going to go looking for things that would distinguish what this is. So acids are super easy to distinguish. Does it start with H? Yeah, here's the H. So this one must be an acid. Then for the second one, I'm just going to go looking for metals. Because metals would indicate ionic, right? Well, manganese is a metal. And then finally, if I look at this last one, it's all non-metals. So this must be covalent. Easy enough. We can do that, no problem. Now, what's this binary part that I keep throwing around here? A binary compound is a compound that contains only 2 elements. So, for example, in this compound right here, MnO2, there are 2 elements, manganese and oxygen. Now, there's multiple oxygens, but we don't care about that. We just care that there are two distinct elements. In PBr3, we've got phosphorus and bromine. Those are the 2 elements. Our nomenclature rules are only going to work for binary compounds, for ionic and molecular. For polyatomic compounds, the rules will still work, but we're going to just use the name of the polyatomic ion there, and it'll be fine. Acids will not be binary. Some acids will be binary, but most of them will be oxyacids, such as the HClO3 that you see on the screen here. All right, so I'm going to put a bunch of these on the screen. What I want you to tell me is ionic, covalent, or acid, based on what you see. Okay? I'm going to hit mute, and someone's going to have to type something in the chat for me to let me know that you finished or what your answers are. Otherwise, I'll have no idea. So see you in a bit. All right, one more minute. We'll go on to the answers. Sorry about that. That was the longest minute of my life, apparently. There was a big thump outside, and I went to investigate, and they're just moving the refrigerator down the stairs from the neighboring apartment because I guess they'd moved out. So if you hear really loud thumping noises in the background, I don't think you can hear it, but that's what's going on. It's not that I'm living in like an apocalypse or something. Although we all are, I suppose. All right, so let's go looking for clues that will tell us what each of these are. So the first thing I do is I just look for H's in the front. So here's an H in the front, and here's an H in the front. Those have to be acids, right? And they totally are. And then, let me change the color on the highlighter here. Now I'm going to go looking for metals. So here's a metal, here's a metal, here's a metal. So those must be ionic, but what else is ionic? Well, ammonium in a compound is also ionic. So these are all ionic. Which means that this leftover one right here, which I gotta get a new color for, this one right here, that's my only covalent. There are the answers. Remember that ammonium showing up is an ionic compound, so be careful. That's how they get you. Any questions, let me know. All right, so now what we're going to do, now that we can identify which compounds are which, we're going to learn a systematic set of rules for each category. We're going to start with ionic. For ammonium, why exactly is it ionic? Because it contains the ammonium ion. Remember that this ion is on your list of polyatomic ions. This right here indicates ionic. Something is only covalent if it shares electrons. Something that's ionic can't do that. It's attracted to the other thing by charges. So whenever you see ammonium, it will always be ionic. Now, the thing about these naming rules is that they are pretty similar. So in your notes, however you're taking notes, like if you have a computer document or you're doing it on paper or whatever, line or separator between when you go from one section to another for this chapter, because that'll be specifically important. What you don't want to do is mix up the rules, because if you do that, you will immediately get the wrong answer. And that's no good. Nobody wants that. Okay, so let's talk about how to name ionic compounds. This is the rule, and it looks deceptively simple. And it kind of is. When you name an ionic compound, you are just going to name the metal as you see it on the periodic table, and name the non-metal as you see it on the periodic table, but substitute the last few letters of its name for Ide. But with all good things, there are some nuances involved. So let's talk about the metal first. So metal names come off the periodic table. Now, depending on where the element is on the periodic table, you may have to treat it a little differently. If the metal is in group 1, 2, or is aluminum, that seems oddly specific, but those are the rules that we're going to follow for this class. Elements in the first two columns, or they're aluminum, you just write the name of the element. Now, depending on your text, you might also see that it includes the following elements in there. So, aluminum, and gallium, and zinc, and cadmium, and silver. And on the periodic table, they kind of make this little stairway. The stairway to silver, we'll call it. These elements tend to be fixed also. For example, zinc and cadmium are always +2, at least in almost every observable species I've ever seen. Silver is almost always +1, and aluminum and gallium are always +3. And so, naming these ions with just their name is done because the ion that forms for sodium is always going to be this, right? Remember how we discussed that, well, sodium has one valence electron, and I get rid of it, that's how I get the positive charge, right? There is no other way for me to get sodium to an octet without it having a +1 charge. So I don't need to give it any special treatment and call it, say, sodium plus or sodium 1 or anything like that. I just call it sodium. The same is true for all of these elements in groups 1A, 2A, or these ones right here. But the only one I really care about is aluminum. So if you treat gallium and zinc and cadmium and silver as having variable charges, that's okay. Now, what do I mean by variable charges? What I mean is, if I have a compound like this, and a compound like this, and I identify that the charge on iron here is +2, because oxygens are always -2. And I identify that this iron is +3. These are different irons, aren't they? I cannot just say iron oxide, because if I do, that would be conflating these two things together, and I wouldn't be able to distinguish them. So for charges that for metals that have charges that can be variable depending on the context of the compound, we have to include their charge in their name. So any other metal that is not one of these guys above here, the way that you name it is you include its name and its charge in Roman numerals. Very important. After the name and before the charge, there are no spaces. Okay? Do not type platinum space parentheses IV close parentheses on Canvas. It will mark it wrong. Be careful. Now, the number that goes in the parentheses is the charge on that ion. So everything that we covered in the Ionic chapter, where we had to calculate charges from all the other ions, you still have to do that. So, for example, if I was going to name a metal compound, we'll go over here to do this. Oops, that's wrong. Let's suppose that I had this compound. Oops, that didn't maximize correctly. For some reason, Photoshop glitches out when I try and load it. So let's suppose that I have this compound. And I ask you, what is the name of this? If you wrote titanium, it would get marked wrong. And the reason for that is titanium is a transition metal. It has a variable charge depending on which compound you find it in. It may have a different charge. So you still have to solve for this. So we know that each oxygen is -2. I've got 2 of them. And I need to have an equal amount of positive charge for titanium. So this titanium has to be +4, right? So the name of this would be titanium parentheses 4. What if I had this? Well, this element is in period 1. Or I'm not period 1, I'm sorry. Group 1. This is rubidium. And in group 1, all ions have just a positive charge, yeah? So I don't need to put the 1 there. And in fact, if you do, it'll get marked wrong. So for fixed charge substances, don't put the number. But for variable charge substances, you do. All right. What about this nonmetal part? The nonmetal with Ide right here is going to take the stem of your element, and then you're just going to stick the word, the suffix "ide" on the end here. Now, you've probably seen a lot of these ides before. There is a table in your text if you need to review them. But we're going to write them out on the next, or on the Photoshop screen in just a second here. So here's an example of what we're trying to do here. Chlorine is the element off the periodic table. Chloride has a negative charge. Know the difference. Ide is used for anions only. Okay? So whenever you hear somebody say something and they end it with ide, they're implying that that is an ion. Are negative charges with a negative, or sorry, I got confused there. Are negative charges with a negative sign in with the numerals or the same as plus ions? So I think I understand what your question is. You're never going to have a negatively charged metal, so you will never see a negative Roman numeral. So note that we have only included the Roman numerals thing with name the metal. You have not seen that yet for nonmetals, so you will not include it there because it won't come up. We do not name nonmetals with Roman numerals, only metals. Did that answer your question? I'm not sure. Anyway, let me know in the chat. Yeah, I did. Okay, cool. All right. So this Ide implies ions. So what we're going to do, I don't know if I have a slide that actually includes all these. Any element ending in Ide means that the element is an ion. For these nonmetals, yeah. So if I arbitrarily just say sulfide, what I am referring to is this. That would be sulfide. If I say sulfur, that's this. Likewise, oxide would be this, but oxygen is that. So let's go to the next page and actually list all these out. First, I'm going to just check my slides to see if these are all already written. It appears that they are not. Okay, so let's write those out ourselves. Maya wants to help too. Oops, what did I just do? I selected the wrong thing. There we go. All right, so the non-metals that we're going to run into are fluorine, chlorine, bromine, iodine. Now, if I add the charges to these, that's how we get our Maya, please. Oh my goodness. That's how we get the Ide at the end of here. So there's our Ide. And all anions, I should say, will contain Ide at the end of their name. We can go over to the next group here. So we've got oxygen, sulfur, selenium. You're not going to see telluride, so we'll just do those three. So oxide, sulfide, selenide. There you go. And then finally, for nitrogen and phosphorus and arsenic, we have nitride, phosphide, and arsenide. I know, that sounds really stupid, right? Arsenide, but that's what it's called. Now, there is one that you should pay attention to. You might hear the word carbide out there somewhere, and you might think, oh, maybe it's this. It's totally not. I thought this for years. In fact, I taught that this was what carbide was. Carbide is actually this. Carbide is another polyatomic ion that you are not responsible for knowing. So don't worry about carbide, but don't accidentally try and name something as carbide. Okay? So it does seem to follow this pattern, but there are going to be other elements out there that end in ide. Or, I'm sorry, not elements, but other ions out there that end in ide, and they end up being polyatomics. For example, cyanide. What element is cyan? I don't know. It's not. It's C and N with a negative charge. That's cyanide. So those are our ides. And so you'll want to know these, or at least be able to reference back to them. And I believe there's a table in the online textbook, but I don't remember where it is. It's definitely in the unit on naming. It's for the OER text, it would be unit 4. All right, so let's practice. Let's try and name some things using these rules. So we're going to have to name the metal, and naming the metal requires us to determine if there is going to be an ion, a charge that we put in parentheses for a variable charge or not. And then name the nonmetal with Ide. We just have to refer to the correct one. All right. So here on the board, I have KBr. K is just this ion in group 1A. And this is just Br minus. This one we know is bromide because we literally just wrote those down. Since this is in group 1A, we do not include the charge as Roman numerals, so we would just write its name. And there would be the name of the compound. KOH is not conductive because it's polyatomic. It is polyatomic, but that's not the reason why it's conductive. You're missing a key word in there. Why am I muted? I think I hit the spacebar again. I'm sorry. Let's try this again. I don't know how long I've been talking here. Let me go back. So you said ionic, and I responded that ionic is the correct term to use because hydroxide is a polyatomic ion, and ions are conductive, which is the whole point of that lab. I don't know if you got that part or not. I have to be careful when I click back over here, because if I hit the spacebar on accident, I think it mutes me. We'll do that now. No, now it's advancing the slides, so. Okay. Let's look at this compound here. So we got Na, which is this ion right here. I got two of those. And I got oxygen, which is this ion right here. So we're going to do what the rules tell us to do. Name the metal, sodium. That's what this is, right? It's in group 1A. So I'm not going to put the charge after it. We're going to just call it sodium. This is just oxide because we just named those. So this compound would be sodium oxide. Now, even though there's two things here, the rules for naming ionic compounds do not say put a prefix in front. They just say name the metal. So even though there's two sodiums, you just say sodium. Doesn't matter how many of an ion you have, you just name them. If you entered anything incorrectly on the lab, and it is before the deadline, you can delete your submission and just re-upload it. I don't download them until the deadline is passed. So just delete your old submission and then re-upload, and that's totally fine. All right, let's do another example here. I've got these two ions here. What I want you to do is I want you to name this metal and name this chloride. Name the Cl ion. I wasn't muted for that one. All right. So type out the names of these two things together, one after the other, and that would be the name of it. Hooray. So go ahead and do that in the chat. All right, so what are the names of these ions here? There you go, very good. So the name of this would be cobalt 2. And we include the 2 because this is not an element that is in groups 1 or 2, and it is not aluminum. And then this is chloride. So that's the name of the ionic compound that you would make when you combine these together. What would the formula be? Well, if I have cobalt with a +2 charge and chlorine with a -1 charge, I need a second one to balance out the charge here. And so this would be the formula of that compound. All right, let's do one more here. I'm going to put Mn and O together, and I'll get MnOPQRSTUV WXYZ, or something like that. I don't know. So what's the name of these ions, and what's the formula that you get when you're done? Type the answer in the chat. Now be careful, there's a typo in your answer. And technically, all of those answers are incorrect in some way. So remember what I said about spaces. No spaces! Ah! The other issue that you have to worry about is no capital letters. Elements are not proper nouns. So don't capitalize the names of elements. So never capitalize elements or compounds. They're not proper nouns. The only thing that you capitalize is you do have to capitalize the Roman numerals. So you do capitalize these. Now, the only time that you do capitalize a compound or an element name is if it's at the start of a sentence, because that's proper grammar and punctuation. This is particularly annoying if you're using something like Word, because Word likes to capitalize the first thing it sees in a sentence or in a table or whatever. Don't do it. Go back and tell it to stop doing that. Don't do that. All right. So if I go back and name this, we know that this is manganese. And it has a charge of 2. So I'm going to give it the Roman numerals 2. Now this is oxide right here, as we've done before. These two just go right together. There you go. All right, so I think that everybody gets the gist of it here. We just have to watch out for really finicky, dumb things that Canvas won't accept as answers. And I tell you this in the questions. Don't capitalize and don't add extra spaces. But if you do that accidentally, it will mark it wrong, and no, I will not go back and give you credit for it. Okay. So be careful. Here's a bunch of examples. What I want you to do is on the top, I want you to turn these formulas into names. And on the bottom, we didn't actually do this, but it's a good skill to have. Turn these names backwards into formulas. So you got to go in both directions, right? As you get the answers, type them out in the chat. We'll go over the answers together in just a bit. All right, I have some answers coming in, so 1 or 2 more minutes, and we'll go over the answers together. All right, let's go over the answers here. I think I have enough space to write on here, so let's just write here. All right, whenever you name these, you got to split up the ions that are shown so you know what to name them. Particularly if the charges are variable. Well, you've probably noticed on this page, because there's a second page. None of these have transition metals, so that's lithium, and that's oxide. So this is lithium oxide. It's just good habit to split all of your ions from your compound together to work towards the name. So for the second one here are my ions. This is beryllium. And Cl is chloride. And then down here we have aluminum and oxide. Now, depending on if your periodic table is British or not, here's the American spelling of aluminum. Here's the British spelling. In fact, if you've watched videos of people from the United Kingdom or Australia or even Canada, places like that, they'll call it aluminium. That I will give you a point for if you type in aluminium on accident. I believe that any question that has aluminum in there has accounted for that, and that I have accepted the alternative British spelling. But just be careful. If you're copying this from a periodic table, I know Web Elements does have the I in it because my periodic table has that here. Cesium has the same thing, so here's cesium in the English spelling, but cesium in the British spelling, they just like to put A next to E a lot, I guess. I don't know. Either of those is fine. Down here, we have K plus and I minus. K is potassium. And I is iodide. So there you go. Those are the first 4 compounds there. Down here for strontium bromide, for turn the name into the formula, whenever you see the name, you should first write out what the ions are, and then put them together. So I have 2 plus and a minus, so I'm going to need 2 of these guys to get to the formula. And we're just going to employ that strategy all the way down. So rubidium is in column 1, so it's +1. Nitride is in column 5, so it's -3. I'm going to need more of these. Oops, I don't know why I did that. I don't know why I did that. God, I wish I could undo. You know, whatever. There we go. Thankfully, you can undo by just going back in the video if you need to copy down any of those things. I unfortunately can't. There's sodium and here's sulfide. I need another sodium here to get my formula. And then here's magnesium. And here's iodide. I need a second one of these. And you should be able to figure out what the charges on all these ions are based on what we've covered in chapters 9 or units 9 and 10. So unit 9 is how to figure out what the charge is for any ion, and then unit 10 will be for covalent compounds. All right, more practice coming up, this time with transition metals. So what I want you to do is, here's a bunch of pairs of ions. I want you to first make the formula and then give me the name of the compound for the top set. And then for the bottom set, I want you to tell me the ions that make these up. And then also give me the formula of the ionic compound. Okay. We'll give you a few more minutes to do that. We'll go over the answers, and then we'll take our break. See you in a bit. 1 or 2 more minutes. All right. Same thing as before. We're going to combine these together. So I have a charge of +3 and a charge of -1. I'm going to need 3 of these bromides. So there's my formula. And then I would name it from the ions. So I have cobalt with a +3 charge, bromide. Over here, +4 and -2, I'm going to need 2 of the oxygen ions. And then the name of this would be titanium 4 oxide. For the next one, I just need 1 each to balance out the charge. For the name, chromium 2 sulfide. That's easy enough. We could do that. Now let's turn the names into formulas through ions. So gold is Au, and this 1 implies, oh, it's +1. Chloride is Cl-, so this must be AuCl. Sodium is Na. Oh, I'm mixing in not transition metals in this lesson here. Nitride is N3-. That looks really bad. Let me try that again. There we go. I'm going to need 3 of these sodiums over here. There you go. Barium, and then oxide, BaO. And then finally platinum 4, so it must have +4. And then fluoride, I'm going to need 4 fluorides here, PTF4. There you go. Let me know if you have any questions on how to do that. Remember that you need to be able to identify what the ions that form are. This was covered in Unit 9. And then how to make the ionic compound. That's also Unit 9. All right, we are due for a break. I actually went over the break time for just a little bit. We'll put this up, take a 10-minute break, kick back and get some more water, and listen to some more Donkey Kong Country 2, because this is the last day we're going to have it. I don't know what's coming up next week. So, let's see here. Where's my playlist? Where are we? Ah, yes, here we go. Well, who's ready for more naming? All right. So the next section that we're going to do is very similar to what we've just done, but it's going to involve the polyatomic ions. Now, I'm putting the boxes for the scheme back on the screen here. But what we're going to do is whenever you see a polyatomic ion that's present, so for example, if I had this polyatomic ion in this compound here. So if you saw this, how would you name it? Well, this is a polyatomic ion, ammonium. What you would do is you would take its name and you would just replace whatever is supposed to go here with that. Sorry, my entire building is shaking as they move things down the stairs, I guess. I was like, what is that? Oh, they're moving another appliance. So whenever you see the polyatomic ion in the compound, you're just going to replace whichever name it should be. So for a cation, you would replace name of the metal with the name of the polyatomic ion. If you had, say, I don't know, if you had this. This is actually this thing, which is called phosphate. Then in this case, you would just replace this box with the word phosphate. You don't change polyatomic names at all. You don't put Roman numerals. You don't put Ide. You just use the name of the polyatomic ion that you have presumably learned from the table at the start of Unit 6. So let's do an example. What are these ions and what would we call this? So this is K+. And if you look up on the polyatomic chart, what this is, you'll see that it is MnO4-. What is that called? It's called permanganate. So this would be potassium permanganate. How about this one? Sodium's easy. We know that. What's the rest of this, though? Well, if you look up on the chart, you'll see that HSO3 with a minus charge is called bisulfite or hydrogen sulfite. Either one is fine. So this is just an exercise of, oh, do you know the names? Drop them in the box. If not, you got to go look up the names. So what I want you to do is, if you don't have the polyatomic ions memorized, and you should, but again, online class, go to find the slides from Unit 6, get that chart on your screen, and use it to name the following ionic compounds. Now, some of them have 2 polyatomic ions, so you're just going to replace both boxes with what's the name of the first polyatomic and what's the name of the second polyatomic, okay? So here are some more examples for you to try. Type in your answers in the chat the best that you can. We'll go over the answers together in about 4 minutes. How are we doing? Let me know. I just got a notification that said OBS reconnected, so I guess I dropped for a second there. But we weren't doing anything anyway, on the stream. So let me know if I'm reconnected and if everything is okay. You may have to refresh your browser in case the bitrate dropped. But it should be working. Be careful on your parentheses on your polyatomic ions. Put the parentheses around the entire ion. Because otherwise the number will say, oh, I have this many of what's in the parentheses right before it. All right, one more minute before we go over the answers. All right, here we go. So what you're going to find is that a lot of these names are very similar, and so you have to be very careful that you don't mix up what is shown on the polyatomics list with the names of the elements or ions that we've already worked with. So NH4 is ammonium, and SO4 is sulfate. So that one's ammonium sulfate. What are the ions that are present there? So we've got that, and we've got that. K is potassium, and ClO3 is chlorate. Let's just write the ions out first. And then you just find them and name them. The next one, barium is +2, carbonate is -2. And then we got lithium, which is just +1, and then dichromate, which is -2. All right, now we got to go in the reverse direction here. So down here we got sodium, and then hydrogen carbonate. And the trick to all these, again, is just recognizing what it is and finding the ion, and then putting them together. So that would be sodium hydrogen carbonate. Or sodium bicarbonate, which you've probably heard of as baking soda. Ammonium is that. Nitrite is NO2-. Be careful, because there are a bunch of these where only this letter changes. So there's nitrite and nitrate. Oops, I guess that would be this one. And then nitride. Nitride is N3-. Nitrate is NO3-. So be careful. And yes, I am going to give you those on purpose just to make sure you're paying attention. And then potassium phosphate. There you go. All right, let me know if you have any questions. I do have some more of them here for you to practice. I'll just do these really quickly because we're going to run out of time if I don't. So I got calcium and then sulfate. We'll put them together. Bicarbonate is also correct. Yeah, so bicarbonate and hydrogen carbonate are the same thing. Both names are used, and you can use either one. Here's rubidium and hydroxide, so we'll just put those together to balance out their charges. Nickel 2 is Ni2+, cyanide is Cn-. So I got to put 2 of those because I need a second one of these to balance out the charge. And then molybdenum 6 would be that. Phosphate would be that. So molybdenum 6-phosphate would be this. All right. So those are some more examples using polyatomic ions. You're going to have to put those polyatomic ions into your ionic compound formulas as you see them. On quizzes and exams, I'm going to mix them all together. So there's not going to be a specific section that just says, name this ionic compound, name this polyatomic ion compound. You're just going to get them randomly assorted. This slide is just telling you, hey, use parentheses, but we already knew that because I've already talked about that. We've been doing that, so. I'm going to skip over this example. I'm going to leave this for you. I do want to talk a little bit about covalent compounds today. And then we'll save acids for next week. So. All right. How do we name covalent compounds? The rules are similar but completely unique. So what I want you to do is wherever your notes are, draw a big line or go to the next page or do something, open a new document, whatever you need to separate these rules from the other rules, okay? Because when I put them on the screen, you're going to look at this and be like, oh, that's pretty similar, isn't it? There's just some minor changes. But those minor changes are what make all the difference. So you have to be very careful that you don't accidentally use the wrong rules here, okay? First, identify if you have something that is molecular or covalent. If there are no metals in it and there's no ammonium, then you're going to name it using these rules, okay? Now, we have not introduced this topic, electronegativity, yet in this class. I'm not really sure why that's showing up here. But the first element is going to be the element that is listed first in the formula. And generally speaking, what this means is that the element that's further to the left or further down on the periodic table is going to be the element that comes first. The second element is going to be the one that's further up or right on the periodic table. Now, generally speaking, I'm going to indicate that for you. I'm not going to give you a compound and say, what's the correct way to name this? Unless I have that example in the next page. I don't. Okay. I think I do that in 161. So the element that's going to be listed first is going to be the one that seems more like a metal. We've drawn the metal, non-metal line on the periodic table. So elements that are closer to that metal, non-metal line are going to be the element listed first. Then, when you are going to name your compound, you just name the first element as it's written on the table. You're going to name the second element as if it was an anion. You name it with Ide, just like we did before. But you'll notice that I have these extra little boxes here. Where'd my cursor go? There it is. These boxes are used to indicate how many of each element are present by writing a numeric prefix. Very, very, very crucial. You only use numeric prefixes for covalent compounds. We did not use them on Ionic. Do not use them there. You use them here only. Now, when we name the first element, we are not including numbers because these are not elements with charges. Remember, covalent compounds don't have charges on them. So there will be no Roman numerals when you name covalent compounds. What are the numeric prefixes that are present? These are in the online text. And we're going to apply these prefixes to something depending on how many there are. So for example, let's suppose that I had this compound. Using the rules, what I would do is I would write out its name as nitrogen oxide, and then in front of them I would put the appropriate numeric prefix. So 2 is di, so I do this, di-nitrogen. And 4 is tetra, so I would write tetroxide. However, for oxide, we actually shorten it a little bit to make it sound better. And you'll see what I mean by some of these exceptions in just a second here. But this is the gist of it. You just stick the prefixes in front of the element name in both cases. Now, there are some exceptions here. If there's only one of the first element, you don't put mono. So, for example, CO2 is carbon dioxide. We don't say mono carbon dioxide. Why? I don't know. It's just something chemists decided. We're going to not say mono for the first element. It'll be implied. Actually, now that I think about it, probably because many elements have one of the first element. I'm sorry, many compounds. Now, if you put your prefix together and you get one of these combinations, so like where we had tetraoxide, we get this AO combination. Or maybe I could have like carbon monoxide. I get this double O. Those sound dumb, so what we're going to end up doing is getting rid of the last letter on the prefix, just to make it sound better, I guess. So tetraoxide would become tetroxide, and monooxide would become monoxide. So notice that I have omitted one of the letters here in each case. This is just a spelling convention that, again, was chosen because it makes things sound better, I guess. This only comes up when you have AO and OO. If you have IO or II, you keep them. So dioxide is fine. Or diiodide, you keep those. That is fine too. And again, cannot emphasize this enough, never use Roman numerals with molecular compounds. These are all covalent, they share electrons, they do not have charges. Therefore, we do not use Roman numerals for them. So let's do some examples here. This is slightly different than the one I did in the previous slide. What would you call this? Well, first, name the elements. Name the second one with Ide. And then we do the numbers. So 2 is di, and 5 is penta. I don't want to get AO, so we'll get pentoxide. How about this one? What would you call it? I'll give you a chance to do this. Go ahead and type your answer in the chat. There you go, sulfur dioxide. Very good. First element is sulfur, the last element is oxide. There are 2 oxygens, sulfur dioxide. How about this one? Give you a hint, we can't call it water. Water is a common name. We wanted to give it a systematic name. What would you call this? Close. We only omit mono on the first element. Got the dihydrogen part, that's right. What are we missing? No, don't capitalize sulfur. Never capitalize element names. The only reason that my answer is capitalized here is because it's the start of a sentence. There you go. Dihydrogen monoxide. Very good. Now, for H2O, we're using the molecular rules because water primarily acts as a molecular compound. It can behave like an acid, but it really doesn't. So if you see H2O, call it dihydrogen monoxide. Which brings up an interesting point. That's a very chemically sounding name. Wouldn't that be interesting if, like, somebody made, say, a petition to ban it? And then many, many people signed it? I don't know, because there is a website out there. And let me find this website out real quick. And this website is, as far as I can tell, a satire. I'm trying to capture all of it, but my mouse isn't cooperating with me. And what this is a website that talks about this compound, DHMO, dihydrogen monoxide. And it has all these scary looking links here. And there is a specific page about substances or effects of this chemical that are out there. And we're going to go over some of these right now. This is just for fun. Dihydrogen monoxide has a few common names, but one of them is hydroxyl acid. And did you know it is the substance that is the major component of acid rain? That sounds awful. Did you know that dihydrogen monoxide contributes to the greenhouse effect? It does. In fact, it contributes more than carbon dioxide. If you're exposed to it, it may cause severe burns. That would be bad. And if you breathe it, you will die. All these things are true. It also contributes to erosion of things like the Grand Canyon, rock formations, mountains will slowly erode away. Everything we know and love about nature eventually will just be destroyed by dihydrogen monoxide. Other stuff, like anything made out of metal, will eventually rust and decay. Dihydrogen monoxide. If you get it in any electrical circuits or whatever, it can cause them to short out and fail. It can ruin your automobile brakes. Every single person who has cancer or has died of cancer has dihydrogen monoxide in them. Like, these are terrible, terrible, terrible things. And it's all true. And despite this danger, dihydrogen monoxide is still used today for the following things. We use it in industry as a coolant. We use it as a solvent. We use it in nuclear power. We use it to make styrofoam. We use it as a fire retardant. We use it in cruelty. Animal research uses dihydrogen monoxide. We use it for pesticides. Even if you wash it, you can't get rid of it. It's still there. It's in junk food and other products. Now, why do we care about this? Because it's fucking water, right? This is all water. Like, of course water does all of these things, right? Yeah, it's fatal if you breathe it. Don't go swimming and take a deep breath. Duh. Yeah, every single person who has cancer has water in them, and every single person who doesn't have cancer also has water in them. Cruel animal research? Yeah, you have to water your animals. Like, animals need water. So, the important part of naming chemicals and understanding how the nomenclature works is because other people understand this nomenclature. And those people may try to manipulate you. You may have heard of people who do not like the presence of chemicals in their food or diet or water or whatever. Those people are morons, because if you want to have a chemical-free diet, I hope you enjoy starving to death, because everything is a chemical, right? A chemical is just some compound. Just like dihydrogen monoxide. Sounds real scary. It's water. It's freaking water. If you read the back of your shampoo bottle, you're going to see all these really scary sounding things. And if you know what the names of those are, then you can go research them. Is selenium really bad? Probably not, it turns out. But you see all this stuff on the back, and people panic, and don't be those people. Case in point, this gag was run in, I want to say it was like Atlanta, for April Fool's Day one year. And so a bunch of people on the radio it was like talk radio, and the two hosts were talking to each other about dihydrogen monoxide. And like, yeah, it's everywhere, man. Have you heard about this stuff? It's in all our water. And then they started listing these things. People had a shit fit. They started calling it in the station, and after like an hour or so, they had been taken off the air. So, don't fall for chemical misinformation out in the real world. And that's sort of what the point of this class is we're just giving you basic chemistry knowledge. And a lot of it, yeah, you're going to use it in Chem 161. But some of it you can use elsewhere and apply it. And so I would encourage you to apply it as much as you can, because if you fall for this stuff and you go to this webpage, you could do a search on this entire website for the word water, and you will find 0 instances of it. Trust me, I've looked. All right, so for the last exercise before we go, I want you to name these molecular compounds using the nomenclature rules for molecular compounds. And then down at the bottom, I want you to write the formula for them. I'll give you 4 or 5 minutes, and then we'll go over the answers, and then that'll be it for the day. See you in a bit. All right, one more minute. We'll go over the answers because we're out of time. All right, real quickly, let me just go over the answers on here. So naming these isn't as difficult because we're just looking at numbers and stuff. So there's two N's, so this would be dinitrogen. And then there's one oxygen, monoxide. Two chlorines is dichlorine. Three oxygens is trioxide. Then we got sulfur. Only one of them, but it's the first element, so we don't include mono. Six is hexa, fluoride. And then we have tetra for 4. Phosphorus. 10 is deca. And it's oxide. To avoid the AO conflict there. Writing out the formulas here, we got diboron, so that's B2. Trioxide is O3. Carbon, disulfide. And oxygen, difluoride. All right, so those are the answers. Let me know if you have any questions about those. And I believe that that is it for naming molecular compounds. Excellent. And that is all the time that we have today. I actually went over by a few minutes. So we're going to call it a day. Make sure that you get your lab worksheet in by tomorrow night is the last call. I'll send out an announcement for that. Make sure that you do quiz 9 and 10. And we will finish Unit 11 next week. So I will see you again on Tuesday. Have a wonderful weekend and take it easy.